In this lesson, we will give an introduction to classification, which is a core component of machine learning and knowledge discovery in databases. We will start with discussing the key differences between supervised and unsupervised learning, define prediction problems as a classification and regression, then discuss what is a model and how to go about training, validation, and testing. The KDD process involves multiple steps, starting from data selection to data cleaning, transformation, pattern discovery, and evaluation. A classification is part of the pattern discovery step where the goal is to build a predictive model based on labeled data. For example, in the email spam detection, we might use a classification step to identify whether an email is spam based on past labeled data. In supervised learning, we have training data with labels that indicate the correct outcomes. Let's walk through this example. In this data set, we are trying to decide whether we want to play golf or not. There are 4 features or attributes: outlook, temperature, humidity, and windy. And notice that all of these attributes are categorical attributes. The goal is to build an automated system or a predictive model where, given these attributes, it's going to say yes or no, hopefully with a good accuracy. Unsupervised learning or clustering is effectively that the class labels of training data are unknown. The goal here is to find patterns or clustering, even sometimes labeling data based on these clusters. In predictive models, there are 2 broad variations: a classification, where we predict categorical labels like whether an email is spam or not. Regression, on the other hand, predicts continuous values, such as the price of a house or what is the temperature tomorrow. Let's take a look at this visualization. As you can see, there's an x-axis, y-axis, blue dots represent observation, and a fitted model, this red line. So what goes in regression, we try to find this model or red line, which is going to predict or approximate the value of a blue dot. So the next incoming blue dot, I should be able to use this red line to predict what's going to be its y value. More general predictive models, learning to rank, such as in search engines, and structured prediction, as in a protein prediction. Let's go over formal notation for classification or predictive models. At the very high level, we'll often use notation xi, yi, where I equals to 1 to n, to represent the samples or the feature set. And these samples are going to be of d dimension. For instance, in the golf example, d was equal to 4. Yi will be 1 to k, representing the classes. So the golf problem was 2-class problem. Either you go golfing or you don't go golfing. Similarly, the spam, no spam is a 2-class problem. But we can have more than 2 classes. Think about the digit recognition application where you get an image of a digit and you want to predict. So here you have 10 classes. For regression problems, yi is going to be a real value. The goal in classification is to learn a model, which we call f hat, that given any feature x test, it's going to predict y hat, and hopefully with a good accuracy. Classification is widely used in real-world applications like credit card or loan approval, medical diagnosis, fraud detection, and web categorization. To build a predictive model like decision trees, we are going to have a training dataset where each sample has a predefined class label, and we are going to keep part of the training dataset for validation. In other words, the validation set is not going to be used in the model construction. In model construction, we only use the training set. Once the model is stable, we can go and test it on the validation set and compute the accuracy. The accuracy is the percentage of samples that are correctly classified by the model. And depending on the value of the accuracy, we either go back and refine the model, or we go and deploy it in the real world, or what we call here the test set. But very often we have to go back and forth between the training set and the validation set. And we really need to be very careful, because overdoing hitting the validation set will result in what we call overfitting. So it's kind of the model memorized the training set very, very well. So when it's deployed in the real world, probably it's not going to do well. So we have to be very careful on the frequency of touching the validation set. In summary, we covered supervised and unsupervised learning, a classification versus regression, and the steps involved in building and validating a classification model.